I'm now happy to welcome Janet Torres, who will be presenting on Magical Realism on Cuban Landscapes, a distant reading of regional development through satellite data. And Janet, feel free to take it away.
Thank you. Let me just share my screen. Okay, so the first thing you might notice about this is the kind of juxtaposition of both the hard sciences and the humanities in my use of magical realism, distant reading, and also satellite data. And that was very much on purpose. I was really inspired by some friends I made in the digital humanities and computational social sciences to kind of have a messy, undefined set of results that you can discuss rather than a clear 2 + 2 = 4 kind of answer, especially because I was limited to the fieldwork that I could do in Cuba by COVID and US policy, which kind of hinders funding for a lot of things. I used a mixture of ArcGIS Pro, R, Sheets, and Python on Google Colab to get this research done. And that was really because none of the tools alone themselves gave me the ability to do the analysis that I wanted to do quickly and efficiently. And one of the main things to remember is that this research is critical of the fact that it is imperialist nations that are spearheading climate change adaptation. And we should be wary of that since the cause of climate change was these kinds of systems to begin with. And one article that really kind of inspired me to take a more critical approach, I was looking at other researchers that had used the European Space Agency's annual land cover maps, which are really wonderful maps that are kind of one of a kind for the amount of time that the time span that they cover, and that they're global, and they go through many different satellites and they have the same classification system. So that kind of standardization really helps when you're doing a long-term analysis like this. And I read this article published in 2022, which basically tried to calculate how much round wood supply was there in the world for Germany to consume in their bioeconomy. Part of the reason why the EU uses a lot of wood is their sustainability kind of measures. One of the things that's more well known is that they consider wood pellets to be a sustainable energy source, a renewable energy source. And in this particular paper, they basically use this data set to see how much roundwood supply was in the world, and then use this metric of sustainability of removing 80 to 100% of the forest cover in an area as a sustainable thing to do. They noted in the paper that Greenpeace recommends a 50% removal. And of course, land that is strictly used for forest plantations was allowed to have 100% removal, a complete clear cutting of an area, which as an environmental planner, I would argue is not sustainable at all. The reason that I chose Cuba is because they've gone through really major economic crises in the 90s when the Soviet Union collapsed. They're quite isolated, they're an island, and they were one of the more developed places in Latin America up until this crisis, and they were primarily focused in the agricultural sector. I used two main data sets for this, the ESA's annual land cover maps and the nighttime lights data set that the US Air Force made. I wanted to kind of give a background to the fact that data sets transfer a value system with them. They're not just unbiased truths. And we can kind of see this I scraped a bunch of the CIA's World Factbook in order to get land cover data back to 1982. And they kind of aggregate or clump together waste, urban, and other land cover types. And then really after 1986, stop tracking urbanized land cover and kind of strictly focus on forest and permanent crops. Things that we could discuss further, you know, what it means to only see these kinds of aspects of a country. Of course, they might have this data somewhere. This is just what is made public. So one of the first analysis that I ran was this kind of net gain and losses of each land cover type. And this is the land cover data, which again is made by the European Union, the European Space Agency. And we can see this kind of, I wouldn't go as far as calling it an obsession, but just a really high focus on tree cover, which, you know, there is a high diversity of tree types, but there is also a high diversity and ability through remote sensing to categorize other land cover types. All of the boxes in red here are different tree types, tree cover types. The ones I was interested in are in the green boxes. Urban, mosaic, vegetation crops means that it's a little bit greater than 50% is vegetation and the rest is cropland. Mosaic cropland is that a little bit above 50% is cropland, the rest is vegetation, and then cropland is primarily crops. And the reason I was interested in these is because this kind of tells you a story about development that I'm familiar with as an urban planner and environmental planner. There is certainly a lot to be said about the very large changes in evergreen trees. Clearly, there are many growing as well as many of them getting cut down. And that could be for forestry purposes that helps the economy in some way. But again, to kind of take a position politically, I chose not to consider tree cover very much in my analysis. One map where it did show up was in forest changes, just because there's a lot of literature out there around where forest changes occur, if they are within protected areas or not. This very large protected area you see here is kind of peninsula, is a very large wetland, and many of these changes could have been natural or human-made. What I find really interesting, though, is in the Pinar del Rio region, there's 3 smaller protected areas that are really popular for tourism because Havana is so nearby. And there seems to be a hotspot of forest loss, not necessarily within the protected areas, but definitely around them. And, you know, we must remember that forests are not just a material source to build things, but also fuel. And this is a country where resources are scarce and they do get hit with regular tropical storms that make rebuilding necessary. I also looked at the kind of intensity changes that happened and what years these changes occurred mostly in. There is nothing that stood out a lot here other than we have this kind of loss in mosaic vegetation and crop, or areas that are primarily vegetation, but with a little bit of crop. What I like to think about this is kind of like a really low intensity cropland, but based off some satellite images and unconfirmed because I couldn't finish my field work there, is that they really went through a process of vegetative succession where croplands were abandoned and vegetation grew. One thing that Cuba is really maybe known for is that there's a lot of buildings collapsing and unfortunate things like that happening in big cities like Havana because of the lack of access to materials. And we also know that there was like a big spike in tourism during some Obama era policies in between the kind of around 2014. So when we see this big spike in urban pixel growth, we also see this growth in sparse and barren, which I did not look into, but they do have contracts with Canadian companies for mining activity on the island. Here is kind of tells another story of what Cuba was doing with their agriculture, really reallocating it. There was some growth in cropland. It's not like they were so strapped for resources that they couldn't cultivate areas of land, new areas of land, but there's certainly a loss in cropland cover. And what the literature says from people in Cuba, at least, is that there was a decrease in the amount of focus on sugarcane cultivation and an increase in the focus on food production to meet their own needs, which is a theme that occurs in a lot of the climate change adaptation literature, and is something that Cuba experienced in this time period. The growth in grassland is another kind of tricky thing. It could be natural grasslands, but there are also major programs around these times where we see increases for meat production in beef and pork, and grasslands are very much necessary for producing beef. So this is something that was potentially captured in this data set. One of the maybe most exciting things that I found was that the agricultural loss happened around the coastal areas of Cuba. And something that happened prior to this time period was that they'd really intensely overcultivated for sugarcane. That was their main export that they had trade agreements to supply the Soviet Union with. And they expanded these fields into areas that were not really suited for intense agriculture. And we see an increase in agriculture, at least here in Eastern Cuba, in the more interior municipalities. And I kind of use this map from the FAO to show that there's vertisols and gray sols in a lot of the areas that had agricultural loss, and these soils are not very good for agriculture. They have high salt content, things like that. I took it a step further and tried to get a sense of where growth and contraction came in the land cover change. This is not my entire table, but one of the tables I used to kind of translate, okay, if you have forest go to urban, that's kind of clearly a growth. You have now urbanized area. Similarly, if there's an increase in cropland or a change to a cropland from something that was not really considered productive for human economy, I considered that a growth. There were, of course, weird things like water turning into mosaic and cropland. Whether or not that actually happened because of a decrease in surface water or an encroachment on these, is something that that you would need local research to do. I did not consider barren land, a change to barren land for growth or contraction. This happened in a couple of other scenarios just because I needed to focus on the things that I had expertise on. But this kind of shows you that through these little decisions that you make about data and how to value something as growth or contraction, you start to put your own value system in it. This is my table from my experience of what is economic growth or contraction. It is not what people in Cuba, in the actual municipalities where these changes occurred, might describe it as. And this is a Sankey diagram that I got from R, and it's a little bit hard to read, but it shows pretty clearly that the mosaic vegetation cropland cover shifted into a forest type cover, which is why I'm saying it was a vegetative succession. So once I take that table and I change all my pixel values to either growth or contraction, I get a net calculation of where was their growth and where was their contraction in Cuba. And we see that it's really these coastal municipalities, and Matanzas is where that peninsula that has a wetland is. They had a lot of sugarcane activity. Have a net kind of negative pixel change sign. There's also interesting things like in Granma province, most of them had negative growth. I overlaid it with mines that the US also mapped, and closed sugar mills in another one. But again, I'm not from Granma. I was not able to visit. When I visited Cuba, I was kind of told not to go to the east. It was very difficult to transit there, so I never made it. But that kind of gives you an idea of where to start to get to more localized research. The second data set, how am I doing on time? Because I can't quite.
We're about at time.
Okay. So night lights, I'll make this super quick. They change over time. Typically they grow since populations and urbanized areas are growing. Cuba has a very interesting kind of flatlined CO2 emissions, which is unlike many other places in the world, partly because they can't afford to import petroleum, so they had to get more efficient with it. Most of their energy production is petroleum based. The other thing that affects nighttime lights is population changes. And for this, again, I had to kind of use data produced by the US Landscan, because it came in remote sensing raster format. There's this kind of coefficient that tells you about the distribution of nights and lights. And the darker municipalities are the ones that have a better distribution of nighttime lights. And those tend to be kind of in this, what I call the spine of Cuba, the central areas of Cuba rather than the coastal areas, which makes sense for storm purposes, but also because that is where the railroads carrying sugarcane products came and went. I did this crazy little clustering thing. I didn't initially think that we would see a lot of areas affected by the 2009 financial crisis in Cuba, but we did see some of them. There's also some localities like the city of Santiago de Cuba, which has a split or a mixture between stagnation and steady growth, which would be interesting to see further. I aggregated them to the municipality level. We see clearly that the coastal areas of Havana, which are the ones that are most visited by tourists, were heavily impacted in 2009. And the area with the slowest growth was in central Cuba, where most of these mills were shut down, sugar mills. And the east saw the most growth, though not necessarily should indicate that they're doing better off. They were in the literature kind of known for being underdeveloped compared to the rest of Cuba. And that's it. I'll take questions.
All right, thank you very much. We'll only have time for about one, maybe two questions. Please put them in the chat and I'll be able to read them out. Okay, I'm not seeing any questions. You're more than welcome to communicate via chat in the future as well. Contact presenters if questions come up later. That didn't come up right now. We're now going to move over to Jeff Meyer on an introduction to open historical maps. Excuse me, open historical map.
All right, I will be right there as soon as I can find my screen. Oh, there it is. Okay. And I don't see what I'm supposed to be highlighting. So is it showing up on your end?
Yes, it is.
Okay, excellent. All right. Well, hey, thank you very much. My name is Jeff Meyer. Min may be in the audience. I wasn't sure if he was going to be able to join me today, but I want to call out the fact that I love the theme of this year's conference, this year's week, because it really is what my presentation is about, kind of unleashing data, whether it's a monster or not, onto our platform. And I look forward to introducing that to us. So I have 3 goals for today, and I'm going to move quickly if I can. and tell you a little bit about what OpenHistoricalMap is and is not. Namely, it is not complete. It has a lot of opportunity there. And for that reason, that maybe you would consider adding some of the data that you have. I've seen some awesome historical data in your past presentations and in this year's. And then I hope that you would consider also using OpenHistoricalMap to display your data. But before we get to that, I would like to point out that, you know, we do, all of us in the University of California system, reside and operate in and around indigenous people's lands. I think it's important to, and they're the original stewards of our lands. I think we need to acknowledge that there's theft and genocide and atrocities and erasure that the U.S. has committed over time. And we should remember the history and contributions and the sacrifices that the Native people have made. There's so many people to mention here. I'm coming to you from the land of the Miwok and the Ohlone. And so I'd like to give thanks to all the tribal nations and ancestors of our California. That's a paraphrase from Gracie Redshirt Tion, who is a Lakota member, and she is out at the University of Colorado. This site, however, I'd like to point out, is a wonderful site. If you haven't seen it, Native Land Digital has footprints and estimated areas of where Native and Indigenous people have worked with the land. This is something that I'm very close to, just kind of as an interest level, because I'd like to get this data in there. But there's a lot of very interesting challenges, and we'll talk about that in a second. But if you haven't had a chance, please go visit Native Land. So OpenHistoricalMap, some of you may be familiar with OpenStreetMap, and there's no subtweeting or texting related to the choice of animals here, just mainly to show that we are a tiny blip on OpenStreetMap. And if you aren't familiar with OpenStreetMap, it's a crowdsourced mapping platform. We'll go through that shortly. And in this presentation, we're going to talk about OHM and OSM and some of the differences between traditional GIS, and also show some workflows going through the data. So here it is. Here is a screenshot that you might see. It's a crowdsourced map. Now, what does that mean? You know, platform. Well, you can see in the upper right, there's me, Jeff Meyer. I am a crowdsourced mapper. Up in the upper left, you can see there's an edit button. So if you want to add information, there's information about objects in the map that you can see over to the left. And we have a time slider, because this is a map of all of human history. And, you know, for that point, oh, and Erin, my next speaker, alert, we have an interest in any maps of the Roman Empire. We think about it all the time. But it goes throughout all of human history. And it's not just at the high level, it's at the low level. And for example, you know, how many people knew that in 1959, California's borders changed? It was very minor, I can assure you, but changed nevertheless. So again, what are the three things? OpenHistoricalMap's crowdsourced map of all of human history, and it's based on OpenStreetMap, which means we get all the cool things that OpenStreetMap has to offer. Why would we do something like this? Well, the idea for it has been around for a long time. There's really no place like it that I know of where you can go in and at all levels, high levels, low levels, add and enrich data across a variety of historical data sets, you know, throw them in your pot and make your cauldron of cool map stew. And it's also a platform, hopefully, that other people can leverage. Now, when we first started this project years ago, I was looking around and I could see that everybody was going through the heavy lifting of trying to build their own servers and everything. And I just thought, wow, wouldn't it be awesome if there were a place that more people could share in, rather than just building up their own websites, et cetera. And technology proceeded. It's a little easier to do this than it was in the past, but I think we still have some opportunities to provide a good platform for other people to reuse. So here's an example. We have you know, California in 1857. There's some more cities there now. And you can zoom in to a regional level. If you know the San Francisco Bay Area, you can see there's no Golden Gate Bridge, there's no Bay Bridge, there's no, there's really no airport there. That came a little bit later. and zoom in, and you can see, aha, here's some information of San Francisco back in 1853 that was taken from an 1853 map. So we have, again, gone from a high level down to a low level, and we can merge with other maps, other data. We can see the footprint of the fire of San Francisco in 1906 here. And we could dive down even further. And this is an example from Denver, but to show building level information. And there's a whole narrative around the railroad tracks and why they're off center, but that has to go to the heart of, hey, all data that you get from other sources isn't always correct or appropriate. So it's sort of like the bona fides of OpenHistoricalMap as a mapping platform, because we suffer the same bruises and slings and arrows and tribulations of all GIS types. And so here, these are some projects that were from the University of Colorado. I'll bring it back to California in a second. But I want to highlight, this, when I said up front, I wanted to see if you guys might consider, very humbly, consider unleashing your inner map monsters or your inner map data monsters on OpenHistoricalMap. It's pretty cool in that you could use a historically correct base map to impose historical information on top of. So, for example, if you were doing something that was related to, the urban development, and you use the current base map, it'd be pretty hard to show what was going on underneath the highways. Well, with OpenHistoricalMap, you can go back and the highways can disappear, and you can see what was going on in those neighborhoods. And you can drill down at a further level and then maybe take a look at what's going on in the, just neighborhood type of information. So you get that more deep level of, hey, we had red lines. Okay, well, how did that actually shape what was going on in the neighborhoods? What were the businesses? What were the stores inside those red lines, in addition to what was the real estate prices? And so, for example, earlier today, and I apologize, I can't remember whose presentation I took, but so each of these types of places, story maps is cool, but it doesn't have historically correct base maps. So where do you get those? Where can you generate those? And what can you lean on other people to provide or help provide? And we hope to provide that service. And it's not just all about county boundaries. It's also about what's not in certain places. So most people know about OpenStreetMap. Or many of you do. If you don't, it's kind of like this online version, free version of Google Maps. Has pretty good data coverage across the planet, good enough for people like Facebook and Yahoo. Nobody remembers Yahoo, rest in peace. But the data set's very rich. Here is at University of San Diego. And people have entered all that data, and you can also download this data. So I heard somebody earlier today make reference to, hey, extracting data and then using it. I am more in the position of, hey, let's think about it not just as, kind of a place to get data. And so in my mind, or at least my impression, is that a lot of people think of OpenStreetMap, and hopefully in the future they'll think of OpenHistoricalMap like this, but OpenStreetMap is a place where you go get data and you download it and then you do stuff to it and then you move on. But really, there's the question, and there's nothing wrong with this. In fact, I've seen a lot of Esri's, and not to pick on Esri, but I've seen these presentations online. They're like, here's how to use OpenStreetMap data. Download it, get an ARC info, and then munge it, and then you can do some analysis. But that data, those books didn't just get on their shelves by themselves. They got there kind of one book or one map at a time. So it was put there by mappers like you or like me, the guy in the upper right-hand corner there. And the question is, how does that data get there? Well, it gets there from tracing old maps or from other uploading data sets that have already been created. I know that University of California is a big fan of georectification. I've seen it on the past GIS week agendas. And so the flow is generally, you have an old map or you have some data, you import it into an editor, you tag it. We have a little bit of a different tagging scheme, and then you can kind of upload it. So for example, say you're here at the UCLA library and you're on their georeferencing site. And, I see some UCLA friendly names there, like Sarah Edwards, and I think Quinn is also from UCLA. And you come to a map that maybe one of them, I think this is one Quinn has done, has georectified in the past. So it's Pacific Palisades and Old Maps Online. It's great. Peter, who runs the site's fantastic. But on every one of those sites that's been georectified, you can get a thing called an XYZ link. If you copy that and paste it into OpenHistoricalMap, you can then see it in an editor and then trace the information on that map. And that took, I just did that last night. It took me all about 3 minutes. You can start mapping stuff. And this is from a map from 1929. So that's not the current campus footprint, but you put metadata on there that tells you when it was, and the editor can filter out so you can edit only a particular time and then upload it. Here's another great example. Adrienne up at Berkeley's, the Bancroft Library they have put a lot of plat maps, which are the old maps of the Spanish and Mexican ranchos, online. And here you have some amazing, primary sources of survey maps. And luckily they use, if you see the little red and blue IIF, that's a data format for images that's used by Berkeley's library in these cases. And there's a site that we have, a friend of mine runs it, called All Maps. And you can go in there and edit it. And this is the part, I can't get any feedback because you guys are on mute, but this is where I would expect all of you to be booing, because you'd be like, why is he georectifying Stanford? Lame, right? But, it comes with the territory, I guess. So, but the point is, no matter what type of map you have, what type of source map you have, we can make it easy for you to rectify it and get it into OpenHistoricalMap and get tracing pretty quickly. In addition, if you know about Sanborn maps, there's a great site called Old Insurance Maps that's dedicated to georectifying and stitching all of those. And again, it has a one-touch button, and you can come directly from that site and edit in OpenHistoricalMap. Or again, back to Berkeley, maybe you've got a data set of old ranchos. And I'm having trouble converting that one, so I haven't gotten it in yet. Or maybe you're going to go to Wikidata and you can find and query some data. And there's lots of information that you can add in here. This is an example of data from Wikidata for cities. And you can see some of the metadata on the right. And I've imported that in using, this is an external editor. And here are some more of the important tags. And you may remember, I put those in a different editor earlier, the in-browser editor. But the main, these essential tags that you see here, the key ones, they're kind of they kind of are the grease that keeps the wheels turning in OSM, and it helps, or OHM, and it helps us actually operate properly. So you want to have a name, you got to have a start date and an end date, because if otherwise, something that you put in the map will have been there since the beginning of time. And as you can see, we go, remember from an earlier slide, we go way back in time, as far as you want to go. We try to tie into other sources of data, so that's why Wikidata is there. And we have to have sources. Big question we get: what if you have differing opinions? Well, if everybody puts their sources in, all the other people who come along and look at something should be able to say, "Aha! I may not agree with that guy or that mapper, but I understand where they came from. I understand what they were doing." And I'm going to add a different thing with a different source. So I'm going to add an additional source and adjust the data. And there are other types of tags we can add to enrich it so that you can have pictures and other types of information. Now, we do have some analytics available inside of OHM. And this is largely a result of the fact that we are riding the backs of OpenStreetMaps. There's all kinds of tools that you can have. And so we just take these tools and we point them at OHM instead of OSM, and we've got some amazing things we can do. So for example, if you want to search OHM and say, hey, what happened on this day? You can see a list of events. You could say, show me all the ranchos in California. Show me all the ghost towns. You can style up the differences. And again, if you've ever worked with Leaflet or any other web-based maps, all the things we're showing you here are easily entered into a map or a web application that you might have running Leaflet. So again, how do you get this data? How do you use it in your sites? Well, you might have an animation of something changing over time. You might be able to style it like this if that's how you wanted to do it. All of it can be embedded inside your websites. And again, we get down to the neighborhood level here. What did my neighborhood in the Mission District of San Francisco look like 20 years ago? Wouldn't it be cool if we had all the stores there, or all the neighborhoods, so people lived here ways back and say, yeah, I remember what that was all about. And this brings me back, if I can get in under the wire here. This is the Bay Area. This is some data I've taken from nativelands.ca. And this is just a horrible representation of mapping for Indigenous people. It's really tough, and it's a challenge. We're trying to figure out how to do it, but because it's difficult doesn't mean we shouldn't do it. And so we are trying to do it. And there is all of history that needs to be represented, and all the truth of history needs to be represented. That's why we're talking about the humanities. And all these presentations are remembering that there is a humanity in the humanities. And so that's it. That's all I have. I can't see the questions right now, but I would love to answer what I can in the time I have.
Thank you so much, Jeff. Very interesting. I was actually going to ask you about old maps online, and then you brought it right up. And we've got a question in the chat from Ryan. Ryan says, as an editor / part of the I'm not going to pronounce that, World History Gazetteer Ancient World Mapping Center Data Ecosystem /Borg, I'm really interested in the possibilities of OpenHistoricalMap and integrating Gazetteer, place data, research data, and geodata with it. Can you speak to any possibilities of mass data sharing or linked open data opportunities, especially with complex geometries and places that are currently unlocated or poorly understood?
So Ryan, when I saw your name there, I knew I was going to maybe get a question like this, and I can only answer it with embarrassment that we haven't entered more data sooner. So I know, I know Carl and Ruth and all those people who are involved, and I think it's just a matter of making sure we do the imports right. I definitely want to do some of those imports, and I think that that's a tremendously rich data set we need to have available. And I'm curious if you have questions about like ways you think it would be the right way to do it. And I'd love some feedback on that, but I'm open. It's critical. And I didn't talk about it, but we are trying to tie back and forth between Wikidata at a minimum and putting our identifiers into Wikidata to start.
Oh, good. And I think part of it too is this idea of like the unknown and the unknowable, especially with digital humanities and geodata. Like, how do we represent something that we don't know? I mean, we know it's there, but we don't know precisely where it's there, or some kind of relationships of like going back to like some of the native boundaries. We don't exactly know where boundaries sit or not, and so how can we represent things that are spatial but are more relational than spatial, or knowledge for them?
Yes, well, the relational element is tricky, but even just the fuzziness, fuzzy boundaries, a range of boundaries, we're trying to figure out how do we represent that visually. And we may have some fun stuff to play with on that front, with related to empires in the not too distant future. So, again, would love to have whatever data you have and work together with you there, Ryan.
Any
No
other
student questions? Tohar's not there? I mean, what's going on here? Come on. All right. I'm very eager to hear the next presentation, so I'm glad to turn the mic over to Erin. And thank you again very much for being host. It's wonderful.
Absolutely. And thank you, Jeff, for your wonderful presentation again. Next, I'm going to introduce Erin Mutch with the very prescient project title of How Often Do You Think About the Roman Empire? Erin, take it away.
Got to get my microphone going here. Hello, this is my view of the Roman floor about a year ago when I was visiting. So hope maybe Jeff's presentation and mine can kind of the questions might be able to go both ways, because there's probably some overlap and some questions about what we're doing and the Open Historic Project. My question for Jeff, when you talk about Carl and Ruth, are you referencing Ruth Mostern and Carl Grosner?
Absolutely. Absolutely.
Okay. Ruth Mostern hired me at UC Merced. Just saying.
I picked up on that. Yeah.
Yes. Anyway, not to do this project, because I'll have to say, when I presented her this project, she cringed and told me it was a bad idea. And you'll probably know why after I share what I'm going to share today. So I'm going to tell a story about a project that happens to use GIS. And this was an homage to all the TikToks that were in my feed about how often you think about the Roman Empire, because at the time I was assembling data of the Roman Empire, and I thought, well, gosh, maybe for UCGIS Week, I'll share this project that's not yet published, that's not yet available, that's a work in progress, but there's a lot of eagerness and a lot of excitement about what we're doing, and I'm trying to use that to fuel all of my fire to brute force myself through all of this project. But basically, so because I tend to forget to introduce myself, I am the director of the GIS Center and Geospatial Services at UC Merced since 2013. So I do a lot of everything there because we are the smallest UC. Not only am I a quasi GIS librarian, I do a lot of GIS research. So this is how I got started at the university, was by being hired to do research like this project I'm going to share. But I also handle the software site licenses, do tech support, teach workshops, do all that fun stuff. So if you want a job that does everything, this is it. So I'll review this presentation. Again, I decided to I try to lighten it up a little bit and try to make it fun. Why are we doing this? This was really, again, going back to some questions like, well, why would you do this? This doesn't make sense. So what project are you talking about? I'll show you in a minute. How did you get the data? What software techniques were you using to do all of this? And then what is the future of mapping the past? And so as many of us in research are finding through, we see tons of example of red line maps and all of this stuff, we're really diving into the importance of historic data as it relates to predicting what's going to happen in the future. And I say that in a broad term because there's so many things that we're doing here. So the primary research questions from the researcher who presented this to me was, they wanted to analyze the correlation of historical indices versus present day occurrences in order to understand the current socio-political status. And they were, they're an economics professor. They're no longer with UC Merced, but they're going to publish the results in the paper eagerly as soon as I get my part done. But they wanted to look at the data versus the NASA EdLights. So the illumination of the world. That was kind of the approach, but there's other approaches to use and other ways that they're kind of thinking of how this data would be used. And so this was so we attempted, and I guess the attempt is a work in progress because we're still doing this, plotting locations of higher order territorial-based polities across the world and across a full-time spectrum. So we have data that is contiguous across the world with different hierarchies, spanning from the beginning of what this is called the beginning of civilization, 3400 BCE to present day. Okay, so that sounds crazy. Whose idea was this? Who came up with this? I don't know how many of you've seen these type of videos online. When this was presented to me, this had like 5 million views, and I was like, "Are you kidding me?" I'm trying to fast forward a little bit, but this is a step of civilization changes. So Justin Cook, who's the researcher is on this project, showed this to me. He goes, "Hey, Erin, this is cool, and I want you. Can you make this into a GIS?" I'm like, "Yeah, why not? I'm desperate, and I want to get some funding to keep my center going, and I'll figure this out. I can totally automate this and come up with just a cool database you can use." goes, yeah, it doesn't have to be that accurate, and you know, but just give us something that we can work with. And I'm like, okay, yeah, I totally can go ahead and do this. And there are other these maps, these videos online, and I can tell you why we use this one versus maybe others you have seen if we have time, but I know the time is limited. So yeah, I was like, roll up my sleeve, let's do this. So I was like, Justin, where's the data? Okay, here's 500 PNGs. Look at these 500 PNGs that came from the movie. And it looked like there was a consistent shape. So I thought, okay, this would be an easy georeferencing problem. Or this would be easy to do. Like, again, I was very confident and excited. And like, this is just going to be just a really easy project. And so this is again a snapshot of one of these maps that was presented to me. Again, we would call cartoon format in a sense, but it was just hand drawn. And I don't have the name of the person who produced all of these maps, but he has all the sources and everything they put together. And with that, each of these maps had a legend. So these legends were color coded towards these polygons in the map. So I thought, okay, in my mind, and again, I'm talking 2014, 15. So this was a while ago when this first came onto my docket here. Was okay, maybe I could do some OCR. I can look at the colors. I can automate. I could run some scripts. I can figure this out, no problem. After I georeference. So I'm not sure, you know, which I should deal with first. So of course, georeferencing was the first thing that needed to be done. And so I went through an inventory of the images. I was able to identify a coordinate system that seemed to work. Created control points for georeferencing, a couple hundred control points. And again, from someone who's georeferenced historic maps before, there is a level of rubber sheeting, and there's a little, you know, you're going to run into errors. It's not going to be perfect. But again, we weren't trying to achieve perfection. We were just trying to represent these maps. And then we were able to batch georeference these 500 images and to find the projection. So this was like a surprisingly fast part of the project. Oh, wow. Okay. I didn't realize it was going to be this easy. And yeah, there was a little errors here and there, but again, the PI was like, that's fine, we can deal with that. That's not going to be a big deal. Back of my mind was saying, okay, if I'm delivering this data in a geodatabase or shapefile and someone overlays that, they're going to see it. They're going to see it. Well, we're going to maybe do statistical stuff, maybe whatever, right? I'll just keep moving. Then I was like, next step, I'm going to automate these polygons. I'm going to go for this. And at the time I was using ArcMap, and there's a product called ArcScan that I've used for other projects that vectorizes rasters if you have some settings. So I tried that. I tried to use zonal tool set. I tried to extract color categories through the legend through OCR. And it's like, and again, I just trial and error, and this should be easy, right? And this is kind of why I have this ancient wall here. I basically hit the wall multiple times. I could not climb over this. And you know, there was a frustration because I thought, you know, I should be able to figure this out. I know I can do this, but I also had a volunteer who wanted to learn GIS. I had some students too. So I said, you know what, I'm going to go ahead and go. I'll consider something, because this uphill battle could not address cleaning up these internal boundaries. Like, there was no way at the time that I could figure out how to clean out the blue, because it would take away blue. And again, this is 2014, 2015. There was too many errors and little fragments to kind of clean up these images. And not enough data would be captured in automation. So we'd be losing data anyway. And then we weren't able to accurately capture the legend items consistently through the images, because the legend on each of these maps was not all of the colors. It only showed like a snapshot of the colors. So even if we wanted to say, okay, we've got, oh gosh, 5 minutes remaining. Okay, we have 5 minutes remaining to cover the world. Okay. So how did I conquer this pending disease? This is the look on my face like almost every day these days. Like, how can I make this go faster? Brute force digitizing maps. Our forward progress was made incrementally. and we utilized an army of students to digitize these polygons and staff. So the process of creating these tiles we were getting them done, half hour, maybe 2 hours at a time. So we were cranking through them pretty quickly. And so the final result, like, I'm done, I'm uploaded the data, good to go. We finished in 2021 again because we didn't have a full-time staff dedicated to this. This was kind of filler work. But we had over 100,000 polygons spanning from 3500 BC to 2014 CE, which was completed in 2021. Put it on box, closed my eyes, gritted my teeth, said I didn't have a chance to review it. So I was haunted by other collaborators who discovered this geodatabase. And of course, these errors came back from the dead. What were those errors? Well, some of them were data entry errors. That's easy. That's an easy fix. Polygons were incorrectly named, some miscoding. Some polygons were left blank because we weren't experts. I'm not a historian. I'm not an expert at this. The other one is spatial inaccuracies. And again, it's good that I wasn't digitizing because I'm the digitizer that does I am very tedious. I am the old school methodology of, no slivers, no overlaps, clean topology, all of these things that I was taught using ArcInfo maybe almost 30 years ago now. Like, those are things that I can't get out of my head, where students who've never touched GIS before, they're like, click, 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 good, we're good to go. So the end result that was produced was these polygons. And again, they're not spatially accurate. If you look close enough, you can see that there's some discrepancies, and the discrepancies were a problem because a lot of the civilizations, the polities, are on the coastline. And if we're not representing the coastline accurately, then statistically it's going to mess up the results of these researchers. So I decided, well, I'm going to find the best coastline available and redigitize all the boundaries to match the most accurate coastline. I could not automate it for several reasons. And the Align Edge Pro that everyone says is great actually could not handle the large data set. It just wasn't performing. I actually burned a hard drive. And then I decided to digitize islands because I thought that was a good idea, but it wasn't. They were too detailed and not necessary for the distribution because we had a 6 kilometer pixel data set that we're working with. So, okay, 6 kilometer was our tolerance. So if you go the difference between the first and the second, the green is what I digitized this summer because I was crazy. And then the orange is our old data. So that was not quite good. And, I mean, this is, again, I kind of have an engineering licensing background. I was like, it's got to be perfect. I mean, this is crazy. Like, what was I thinking here? Like, why does this area representing, BCE 3000, or not 3000, but I don't know the exact time. Why do I have to have, Dubai in there? Really? Like, because I was using the most accurate coastline available because I wanted the data to be right. So with some course correction, we found a course shoreline data to match this coastline. We used some processing tools to automate as much as we could. Spatial join line features, Union Clip, we pushed stuff to GeoPandas, stuff's kind of all over the place. And now we have, the purple is now what is like, this is the data we're going to share. This is the data that's going to be published. It's not perfect, but it's clean, it's smooth, and it's going to load because we need the data to load into either Google Earth or any GIS products. So the outcomes, our accurate data cannot be utilized efficiently across the entire database. The corrected data reflected the original data source while matching to an accurate reference. Again, the issue was coastline alignment. And now these data can be utilized in graphic and non-graphic programs, supporting a broader range of researchers. So we're not just, we're able to get this maybe out to a broader audience that's not going to rely on geospatial visualization tools. So our future vision is distributing these data via an API, which will allow researchers to query a polity and a year. So it doesn't have to be a graphic interface. Also, the vision is to have an interactive map to review and download snapshots of data. And then our audience currently are researchers that can consume and contribute updates. So right now the data is not, this is an open data source. It's being reviewed by researchers in Oxford. It's not, again, we're not ready to kind of it's like Prince's demo tape that got released after he died. I don't think he wanted that released. So that's kind of where we're at. So I sped through things because you're like, well, what did we do? We covered the entire world geopolitical boundaries as best as we could with that data source. And the data is now being reviewed by historic experts. And next steps, again, I hope to see this data being shared and distributed. I know the researcher wants to do that. So we're not trying to, gatekeep it by any means. But I'm hopeful that I'm excited that this product, we're seeing the end of the light here, or the light at the end of the tunnel. So that's, sorry to go long. Or did I go long? I guess not. Any questions?
Thank you so much, Erin. This is really fascinating, really interesting. Ryan has asked, which coastline at which time did you spend so much time trying to?
The Greek islands really tore me up because the data that we had back here overlapped islands, and in the Greek, and again, the detailed coastline shapefile that I was using to do the line edge was really detailed, and just again trying to make a decision on what islands to keep, what to get rid of. Like I'm like, oh, I visited Santorini, so I want to include that. Well, no, just because I visited a Greek island because I was lucky enough to go there doesn't mean I should include it in the database. But I think you tend, at least I tend to really get into the wormhole of like finding out about an area, and then I got this book that from Irvine Atlas. I can't see my blur screen, but that I'm going through and I'm peeling, and it's like, wait a second, my job is I'm just the person trying to clean up the coastal boundaries. So I actually use the NOAA boundaries, that the coastal boundaries that they use, but there was a lot of shards in them. And when I was using the align edge to match that, it just wasn't cool. So I'm using the world generalized coastline shapefile that I think is distributed by by the Esri Arc Hub. But yeah, and also we're releasing the data in GeoJSON format right now for review, in addition to shapefiles.
A question we have from Anthony in the chat is, can you tell us about the researcher that made the original maps and how were the original polygons produced?
So the researcher that made the original map, they have an agreement with our researcher. I don't know their name, but there's a 30-page Word document of all of the sources they used. So all those sources will be integrated into, the I guess the released data eventually. What was going to happen with the data, like somebody was actually going to turn it into a GIS.
And a question from Kiana, did you find any spatial insights about present day sociopolitics based on history?
Well, I'm not the researcher consuming the data. So what I'm noticing over time, some have piecemealed it out and looked at kind of transitions in history and things like that. There's another researcher who's looking at solar eclipse data and kind of correlating solar eclipses over time versus geopolitical changes. So it's kind of like, it's a little bit, it's a new frontier really in a lot of ways as far as who's using the data. The goal is it's going to be housed in a world data bank that is managed by a group of experts, but as far as how the data is being used for research, that's hopefully we'll have all of our ducks in a row, so if they use our data, that they'll source it and whatnot. But I mean, those are really good questions. There's, again, looking at the data, like how often I'm thinking of the Roman Empire, I start to daydream and I'm like listening to podcasts and like trying to learn about all these areas. It's just really fascinating.
Awesome. Well, thank you again, Erin. There's a final question from Ryan in the chat, but in order to try and move things along and keep us on schedule, I won't be asking it right now. And next, we're going to move to Reshmi Mukherjee, who is going to present on the California Great Shakeout in 2022 for emergency management.
So, hi everyone, good afternoon. And my name is Reshmi Mukherjee, and I work at UCSF as a GIS engineer. And we are an Esri shop, and what I'm going to present today is a pilot of Esri's emergency and disaster management solution during California's Great Shakeout exercise. So, the Great Shakeout exercise is an emergency drill, which is California-wide, and UCSF decided to participate in 2022. And this is just a showcase about the solution and how we adopted it for our drill. The goal was to assess the enterprise-wide readiness to respond to a catastrophic earthquake of a magnitude of 7.8, which will occur along the San Andreas Fault. This is a California-wide exercise, and just to see the readiness in case of such an event occurring. For the drill, like all the UCSF campuses, namely, we have the campuses at various locations in SF, Mission Bay, Furnaces Heights, Mount Zion, as well as we have the Benefit of Children's Hospital at Oakland, who also participated in this drill. We identified about 33 buildings, and some of which will be assessed on the impact of the earthquake. The GIS team, which falls under the Realistic Business Intelligence, coordinated to understand the requirement and interface with for the project stakeholders to gather the data, information, and work on the solution. We adopted the Esri's emergency and disaster management solution. It comes in with several components, but it's suited to UCSF needs, we adopted about 4 components. One thing that we decided is to digitize or to make it like a digitized form of ATC Council's Rapid Assessment Form, also known as ATC 20. And it was converted using Survey 123. Adopted a crowdsourcing application called Quick Capture. Esri's photo attachment viewer was used for photo gallery viewer for all the captures or all the photos that we received through Quick Capture. And finally, another thing that we added, and which was not part of the solution, was to add a dashboard to display our results. The dashboard was displayed on a big monitor at the emergency control, which will help the stakeholders to deploy appropriate measures. So in real time. So, I mean, of course, this was a drill, but it was in preparedness in case such an eventuality happens. We had several objectives. One was definitely to leverage the GIS technology over cloud to build resilience and get the ATC 20, which is actually a paper map. There is 2 versions, a detailed and a rapid assessment version. For the drill, we decided to use a rapid assessment version, and it was converted through Survey 123 Connect into a mobile and web-based app. Quick Capture, a community platform to submit hazards and images. And of course, we had to add a dashboard, which will use the power of what and where, basically. So, I mean, all the captures or all the assessment that was done on the field would be sent to the EOC at almost near real time. So the first is the first component, which was the Survey 123 data. Now, in 1989, from the funding of California's Governor Office of Emergency Service, Office of Statehood Health Planning Department, and FEMA, ATC Council published the ATC 20 Rapid Assessment Form. The goal of the form is to assess building safety post an earthquake. Volunteers, especially structural engineers and building inspectors, will go on the field after the earthquake and mark them whether it's a green, red, or yellow based on whether it's apparently safe, limited entry, or is an unsafe building to enter. And this is how the paper form looks like. So what I did is like, I kind of like took the form and used it so that it becomes easier for the field inspector to use, slightly differing the order of the form, but of course retaining all the components of it. And it was done through the Survey 123 Connect. So one of the things that went a lot of time went was the preparation of the data. UCSF is a large organization and have several data sources which were not integrated. So we worked with different teams to identify the data source and integrate it so that they can be used for the Survey 123 Connect. Most of the data was, at least for the ones that we needed for the exercise, was integrated in a CSV file and put it in ArcGIS online, and basically use the calculation for full data to auto-populate some of the fields. The workflow is like, once the inspector chooses the building name, it automatically populates certain fields. Basically, one of them is an important field, which the building can. It's a unique identifier for all buildings in UCSF. However, we realized that we do not have some data for some of the buildings. And so that was one of the lessons learned and next steps to follow, so which I'll come back to it later on. Some fields are, of course, these are fields, for example, the inspection time and inspection date. These are system generated. The other requires the user input from the inspectors or the structural engineers. And this is just a snapshot of how the form looks like in the browser-based version. Now, in case of a no connectivity or offline situation, which is a very real probability in case of a high magnitude earthquake, these items would be saved either in your send or your outbox. And once it can be downloaded when data connectivity is achieved. So, for example, if you're on the field and there is no connectivity, in all internets are down, the application will still be able to collect all the data. And once reaching the emergency control room, maybe the net connectivity will be available. At that point, this data can be sent over the cloud. Now, all the data that we deployed, we created flyers and we were able, like, user guides, and all of them had the QR code, either for easy reference for internal UCSF staff, as well as for anybody who is like, we had a crowdsourcing act. So we had citizens who also participated in the drill. The next next adaptation that we did was the big button. It's a public assistance survey, quick capture. So quick capture is like, it can be pretty quickly created using the quick capture designer. It's a web-based designer where you can have your categories. We basically decided on 10 categories that's given over here. And once the user chooses, the application automatically turns on the camera. At that point of time, you can take a picture and send over the capture. With the help of UCSF-PED, we were able to create and distribute flyers all across the campus. Since this was the drill, we were trying to see how much crowdsourcing we can get, as well as get more participation from the UCSF staff internally. The UCSF Police Department helped us to deploy or send this flyer across the mailing system so that all UCSF staff would participate in the exercise as and when it is safe to do so. All the pictures that were collected, was used with the ArcGIS, was displayed with the ArcGIS photo attachment viewer. The photo attachment viewer is a configurable app, which is like map-centric, or as you zoom in and out of the map, the images changes in the gallery, or you can click on each of the photos for a browsing experience. And I'll quickly go over the, so this is the dashboard. I hope I'm still sharing. So this is a dashboard which has has an integrated dashboard, has several dashboards within one dashboard. So once you click on the building, you get the auto population. There are certain information that we already have, maybe type of construction or what kind of a dwelling it is, whether it's a housing or a hospital. It auto-populates my name, the inspection date, and so on and so forth. The rest of it, like the evaluation part and what kind of posting, the posting is only of 3 types, whether it's a green placard, yellow placard, or a red placard. And then you submit. As soon as you submit the form, it comes over cloud to the dashboard right over here. So this dashboard has few components. It has a running list, which keeps on populating as and when the new postings. The postings means like when the surveyor has, or the inspector or the structural engineer has marked the building as whatever category it is, what kind of placard it would get, it would come as a running list. The bottom is a table on the lower left-hand corner, which shows the detail of the inspection. We have several indices, how many buildings are marked as red, green, or blue, and a pie chart, a simple pie chart. Some filters are here. What we can filter based on posting. If we filter based on name of a building, it will show what kind of, whether it's unsafe, if the building has been deemed as unsafe or not. Filters on inspection name, what campus the posting is from, and a very key component for us was the seismic rating of the building. Whether the building, if the building is like 4 or 5, we would carefully monitor it, especially if it is deemed as unsafe. The next one is a simple dashboard with the quick capture, all the captures that we got from that day. We got about 131 submission from about 90 users over a span of 4 hours. And this was all UCSF students or staff. And I think which was a good, we felt that for deployment of a crowdsourcing app, it was a moderate success. And as we go in and out on the map, all these indices kind of like changes. So these are breakdown about what kind of hazard has been like reported. We had the 10 categories. And also finally the photo viewer. So the photo viewer is map centric. So you have the 2 versions. So either if you click on the image, it gives you like who submitted it and what kind of like hazard it was. And if you zoom in and out of the map, the photo gallery changes. So that's a brief demonstration of the dashboard that I had. For training and participation, we had several teams within UCSF who participated, namely campus designing and construction and building permit services. Technical expertise was from the GIS team and also from the planning team. Several members from UCSF, real estate, acted out, the participants, that these are field inspectors who are out on the field. We kind of got the input from the management to keep the project incorporated. And we provided the training on how to use the form and create a user manual, which is as detailed as how to log into your ArcGIS online, and how to use the form, how to do the submission and things like that. Now, regarding takeaways and enhancement, I think one of our biggest lessons is to understand that we should get more documentation regarding the user acceptance. Like, some of the things that we should have done and will do it in future is that make some of the fields as required field, because we had a submission without the building name. And once the submission went, it was kind of difficult to locate it on the map. Prevention of duplicate record. Each building should have only one posting. Create another category called black, which is for completely destroyed building. But our ongoing effort is to integrate our databases, find where the data lies and integrate them, and use GIS database as a master reference, drawing data from various internal UCSF data sources. And another enhancement that we have also got feedback is to create a geocoder with the campus location for the quick capture app. So yeah, I don't know how fast I went, but yeah, that's my brief presentation about our drill that we participated as an institution at UCSF. Thank you.
Fabulous. Thank you so much, Rashmi. That was really, really interesting. So far, we've got one question from Kiana asking if we can have access to the dashboard.
I really don't know how to answer this, but right now it is not. It is only restricted to the organization and not available to the public.
Any other questions? Again, please put them in the chat.